We are starting Chapter 8, Section 2 today on Pythagorean Theorem. Most of you are already very familiar with this, so hopefully this won't be very difficult for you. You should know that a squared plus b squared equals c squared is what we call Pythagorean Theorem, where a and b are the legs, meaning the two shorter sides of a right triangle. And remember, this only applies to right triangles. How do we know if it's a right triangle? We look for the little box, or we can be told that this is 90 degrees. You can see it written either way, but you have to be told it's a right triangle in order to use this formula. The important thing is that you know C is this longest side. That longest side has a special name called the hypotenuse. You can find it a couple of ways. You can look and see if it is the longest side or not, as I just said, or you can find the box, that 90-degree angle, and go straight across, and that will always be your hypotenuse. So the hypotenuse has to go here in the C position. Now, your legs, A and B, can be flip-flopped because we're adding. Remember, if I said 2 plus 5, that's the same as 5 plus 2. It doesn't matter what order we add in. So A and B can be flip-flopped, but C has to be the hypotenuse. So let's do an example. Find the length of the hypotenuse of the right triangle. Tell whether the side lengths form a Pythagorean triple or not. Okay, well, first of all, we need to find this missing side. They tell us it is the hypotenuse, so we really don't need to recognize that. That means my other two numbers are my legs, so they're going to go in positions A and B. And then my hypotenuse is in the position of C. We could call it anything. We don't have to call it C. Okay, then we just do the math. Okay, so we start off with the hypotenuse, squaring it, plugging it into the parts to A, B, and C. Again, you can write it either way. Remember the equal sign, it's like a teeter-totter. Think of this as the fulcrum. As long as it's balanced on both sides, it doesn't matter whether I put the 5 squared plus 12 squared on the left side or if I put it on the right side. It means the same thing. Now if we do the math, 5 squared is 25. 12 squared is 144. So I just do the multiplication. Now I'm going to add them, and I get 169. Last step, remember we don't want x squared, we want x. The opposite of squaring something is taking the square root. Therefore, I take the square root of both sides. What times itself is going to give me 169? Again, be familiar with where that square root button is on your calculator. Everybody's is different. So, this missing part, this hypotenuse, is 13. Whenever you have three whole numbers that work in Pythagorean theorem, that is called a Pythagorean triple. We call these integers. So because the side lengths are integers, they form what is called a Pythagorean triple. You need to know that term. It's when all three sides of a right triangle are integers or whole numbers. And it comes in handy if you start to recognize those. You know, another one is 3, 4, 5. That is a Pythagorean triple because all three sides of this right triangle are integers or whole numbers. If I have multiples of these, it's also a Pythagorean triple. So I could have 6, 8, 10 because I multiplied all three sides by the same number, by 2. Then 6, 8, and 10 would also be Pythagorean triples. What if I multiplied them by 5? What would be my Pythagorean triple triangle? 3 times 5 is 15. 4 times 5 is 20. And 5 times 5 is 25. So this would also be a Pythagorean triple. Okay, so anything in the reduced form, and then any multiples of those. As long as they are all three whole numbers, it would be a Pythagorean triple. So here's some examples and definition of Pythagorean triple. If the measures of a right triangle are whole numbers, the measures of the sides are Pythagorean triple. 3, 4, 5, 5, 12, 13, 8, 15, 17. Okay, these are just a few of them. They go on forever because again, we could have multiples of those. So let's see what the side length. Here we're looking for the leg. So I always start off writing my equation. A squared plus b squared equals c squared. Remember, you can write it the other way. C squared equals a squared plus b squared. Means the same thing. So we're just going to go through the steps. Okay. First, we're going to substitute. So you got to find that hypotenuse, find the box, and go straight across. Here we don't know if that's the longest leg or not, or the longest side, because we don't know what the x value is. So we have to go straight across from the box. That's going to be our hypotenuse. Then a and b, remember, can be in any order. So my other two sides, 7 and x, are going to go in the other two positions. Don't forget to square them. 14 squared is 196. 7 squared is 49, and then my x squared. Okay, then I subtracted 49 from each side, so if you want to write that in, you can. You know, if you want writing these down in your notes to refer back to later on. 196 minus 49 is 147. And then remember, I need to take the square root of both sides. Don't forget that step. And you may not notice this. You may not see this perfect square in there. So you can leave it as the square root of 147 if you want to. But if you recognize there's perfect squares in there, go on and simplify it. You'll have to do this next year in Algebra 2. So I can rewrite 147 as 49 times 3. 49 is a perfect square. Therefore, I can take the square root of that and pull it out, which is 7 square root 3. Is this the exact or approximated value? You need to know that. Okay, so how would I do this one? A squared plus b squared. Start off with your formula, equals c squared. Do I know one of the legs? Yes, it's 8, so I'm going to plug that in. Do I know the other leg? No, so I'm going to leave it as x. Do I know the hypotenuse? How do I know this is the hypotenuse? I find the box and I go straight across. So yes, I know the hypotenuse. Now I square. When I subtract, I get 161. Take the square root, take the square root, x equals 12.7. Remember to round according to your directions. So it said to round to the nearest tenth. Is this the approximated or the exact value of side AC? Okay, this one is going to be a little challenging. It's coordinate geometry, so you're going to have to use your coordinate grid and your coordinates to figure some of these distances out. In order to know if it's a right triangle, you need to know, does a squared plus b squared equal c squared? You're going to have to find these distances and then plug them in. You could also find the slope of these two legs and see if they're opposite reciprocals. That would tell you that these two lines are perpendicular. So that's another way to do it. Okay, but if we find the distance of all three parts, that's going to tell us if it's a right triangle or not. Okay. So a squared plus b squared equals c squared. That allows us to find the distance here. 4 squared, 16, and 36 is the square root of 52. Okay, we can do the same thing over here. Remember how we used to draw the right triangle in? Okay, so this distance is 6 and 4, so it's going to be the same thing over here. So square root of 52. Now we're going to do the same thing. We're going to make a right triangle out of this leg. Our distances are 2 and 10, so 2 squared plus 10 squared, 4 and 100. Okay. Well, what is 52 plus 52? Is it 104? Yes, it is. So is it a right triangle? Yes, it is. Okay, remember there's always more than one approach to a problem, so just think about it. Think it through. Use what relationships pop into your mind. Okay, we need to determine if these are sides of a right triangle. Okay, so we know that if we have a right triangle, we can say a squared plus b squared equals c squared. Now we need to know, do these three sides make a right triangle? Well, if they do, then a squared plus b squared equals c squared will be a true statement. It will be true. So let's plug it in and see if we get a true statement. Does 9 squared plus 12 squared equal 15 squared? We got to figure it out. Whoops, plus 144 equals 225. Well, 4 plus 1 is 5. 8 plus 4 is 12. Carry the 1 plus 1 is 2. Is 225 equal to 225? Yes, it is. So then the next part says, then state whether they form a Pythagorean triple. What makes it a Pythagorean triple or not? Whether these three numbers are whole numbers. Are they integers? Yes, they are. So the answer is yes, they are Pythagorean triple. Okay, so here's all the official everything I just did, only nicely and neatly done. Okay, so here's another one. Are the following sides of a right triangle? So you should try to do this. What would you do? Think it through. Okay, be ready for the lesson. Be ready for your problems tomorrow in class by practicing, by seeing if you understand. You could even do this one in your head. What is 6 squared? What is 8 squared? What is 10 squared? And will that be a true statement? 36 plus 64 is 100, so yes, it is a right triangle. So you get the idea? You're testing it to see if it's a right triangle. We're not assuming it's a right triangle. We are plugging it in to Pythagorean Theorem and seeing if we get a true statement. What about 5, 10, and 15? Okay, and you have to put the bigger number. You have to put this bigger number in the C position because the hypotenuse, remember, is the longest side. So if this is a right triangle, this would be the hypotenuse and it would have to go over here. So now let's work it out. What is 5 squared? What is 10 squared? What is 15 squared? What is 25 plus 100? Does 25 plus 100, 125, equal 225? No, it does not. That is not a true statement, therefore it is not a right triangle. Well, if it's not a right triangle, what is it? It has to be either obtuse or acute. Here's how you figure it out. If I had 125 and 225, what kind of inequality sign would I put there to make this a true statement? Is 125 greater than or less than 225? Well, obviously it's less than. So here's where it's backwards. If a squared plus b squared, this 125, is less than c squared, this is an obtuse triangle. If your a squared plus b squared side is greater than your c squared, then it's an acute triangle. Okay, so these are statements you need to know. Let me write this one generically. If a squared plus b squared is less than c squared, it's obtuse. If it's greater than c squared, it's acute. And then obviously, if it equals, it's right. Okay, so you need to know these rules. Greater than is acute, less than is obtuse, and equal to is right. Okay, so come in ready to use these rules tomorrow. See ya.